All right, let's talk cloud databases. Picking the right one, that's a huge decision. So today, we're going to lay out a complete blueprint for Azure SQL's Platform as a Service or PaaS options. The goal here is simple, to give you the clarity you need to build the perfect solution for your app. Let's dive in. Here's our game plan. First, we'll get on the same page about what PaaS even is. Then we hit the big one, your first major choice, SQL database or SQL managed instance. After that, we'll dig into how you power up your database. Check out the express lane for migrations. And finally, we'll talk about that all-important safety net that keeps your data protected. It's a whole journey, so let's get moving. Okay, Section 1, welcome to SQL PaaS. Before we start comparing features, let's just take a step back and ask, why are we even talking about this? Well, it's because this is really the foundation for how we build with data in the cloud today.
Let's be real for a second. Who here actually enjoys those late-night patching windows, or that nagging feeling in your stomach wondering if the backups really worked last night? Managing all that hardware, the operating systems, it's a ton of work, right? It's a huge drain on your time and energy. Well, that exact headache is the whole reason PaaS was invented.
You can think of PaaS as a kind of deal. You're basically telling Microsoft, hey, you handle all that boring underlying stuff. The servers, the operating systems, the security patches, all of it. And in exchange, you get to pour all your focus into what actually matters, building great applications and working with your data. It's an absolute game changer.
So, Section 2. This brings us to the first and honestly the most critical fork in the road on our blueprint. This is your first big choice. Are you going with Azure SQL Database or Azure SQL Managed Instance?
And the way to answer that question comes down to this. Are you building something brand new, from scratch, something that's born in the cloud? Or are you taking an application that already exists on premises and moving it to the cloud? If it's a new cloud-native project, Azure SQL Database is almost certainly where you want to look first. But if you're doing what we call a lift and shift, well, Azure SQL Managed Instance was literally built for that job.
So yeah, Azure SQL Database is just fantastic for new development, mainly because it's so flexible. It's a really low-maintenance way to go, designed around individual databases. But it gives you these incredible deployment models that let you manage your resources with surgical precision, whether you're running just one database or thousands of them.
Now on the flip side, you've got SQL Managed Instance, and this thing is the undisputed champion of migration. Why? Because it's not just a database. It's a full-blown managed SQL Server instance living in the cloud. It boasts nearly 100% compatibility with what you're already running on-prem. That means things like SQL Agent, cross-database queries, they just work. And this makes it possible to move your apps with very, very few code changes, if any at all.
All right, on to Section 3. Let's follow that first path, Azure SQL Database, a little further. We're going to break down the different knobs and dials you can turn to configure its power, its performance, and of course, its price. First up, deployment. You can go with a single database, which gives you its own dedicated set of resources. Perfect for an app with a nice, stable, predictable workload. But then there's elastic pools, and this is where things get really clever. Think of it like a family data plan for your cell phones, but for databases. You buy one big pool of resources, and all the databases in the pool can share it, using what they need when they need it. For SaaS apps or spiky workloads, this is an incredibly cost-effective way to operate. Okay, next question. How do you want to pay for this? The older model is DTU. The easiest way to think about it is like ordering a combo meal. It's a simple, prepackaged bundle of compute, storage, and I/O. But what if you want more control? That's where the vCore model shines. This is like ordering a la carte. It lets you scale your compute power and your storage completely independently of each other. That gives you so much more fine-grained control over both performance and cost. And once you're in that vCore world, you've got to pick a service tier. General purpose is your workhorse, great for most balanced workloads. Business critical is the top-of-the-line option for your most demanding applications that need incredibly low latency and the highest possible uptime. And then there's Hyperscale, which isn't just a tier. It's a totally different architecture designed for ridiculously large databases.
Now, inside that general purpose tier, there's this amazing option called serverless. Check this out. When your database is busy, you pay for the compute. But if it sits idle for a while, you can set the timer, say an hour, it just automatically pauses itself. While it's paused, you stop paying for compute completely. You only pay for the storage. The second a new connection comes in, boom, it wakes right back up. For dev test environments or apps with really spotty usage, this can save you a ton of money.
So let's circle back to that hyperscale tier for a moment. For the longest time, the practical limit for a lot of cloud databases was stuck around 4 terabytes. Hyperscale just obliterates that barrier. We're talking about a single database that can grow to over 100 terabytes. Just think about that for a second. It completely redefines what's possible at scale in the cloud. And that massive storage capacity is really just the beginning of the story. With Hyperscale's architecture, things like backups and restores are no longer tied to how big your data is. You get backups that are nearly instant, restores that take minutes, not hours or days. You can scale your compute power up and down on a dime and spin up read replicas whenever you need them. It's pretty revolutionary.
Okay, time to jump to section 4. We're going to backtrack to that other path on our blueprint. We're getting on the migration superhighway now and taking a much closer look at what makes SQL Managed Instance the absolute best choice for moving your existing stuff to the cloud.
You know, this quote right here, it says everything you need to know. The number one reason to choose SQL Managed Instance is its incredible compatibility. It's engineered to look and feel almost exactly like the SQL Server you've been running in your own data center for years. And that makes the whole migration process so much smoother and less risky. And you really see that compatibility in the details, the features that your on-prem apps depend on. You've got SQL Agent for scheduling jobs. You can do cross-database queries. You can even get into system databases like TempDB. It even has a feature called Instance Pools, which is a super cost-effective way to migrate a whole bunch of smaller SQL instances without having to go through a massive consolidation project first.
All right, let's wrap this up with our fifth and final section, the PaaS safety net. Because no matter which option you choose, SQL database or managed instance, Azure SQL comes with this powerful, built-in set of features designed to keep your data available and secure 24/7.
You know, one of the most beautiful things about PaaS is that backups are just done. You don't have to think about them. The platform is automatically taking full backups every week, differential backups every 12 hours, and transaction log backups every 5 to 10 minutes. This constant rhythm is what gives you the power to do point-in-time restores, all without you ever having to lift a finger to configure.
And for that what-if disaster scenario, you've got failover groups. Basically, this creates a complete replica of your database in a different geographic region. But the magic is that it gives your application a single, unchanging connection point, a listener. If your main region goes down, the system fails over and that listener automatically starts sending all the traffic to the new primary database.
So what's the bottom line here? It's huge. No more frantic 3 a.m. phone calls to wake up developers to change connection strings in a bunch of config files. From your application's point of view, the failover is seamless. This one feature solves one of the biggest, most painful parts of traditional DR planning. So there you have it. That's your decision-making blueprint. The path is pretty clear, right? You start with your main use case, new app, or migration. That points you to your platform. Then you dial in the power and performance to fit your specific workload. And throughout the whole process, you can just relax a little, knowing that the platform's safety net has got your back with backups and high availability.
And all of this leads us to one final, really interesting thought. If the cloud is managing the hardware, handling the patching, taking the backups, what happens to the people who used to do all that? How does the role of the DBA, the database administrator, change? How do they evolve from being keepers of the machine to becoming true strategists for the data itself? It's definitely something to think about as you're building your next generation of applications in the cloud.